Hi, and welcome to Analyzer Shorts, the series where we show you bits and pieces of AnalyzerPro, the accident analysis software that should inspire you as a reconstructionist. Today we're talking about collision analysis, and this time about the automatic collision analysis. So what we have here is a crash test of Ford Mondeo against an Opel Vectra, and you see the runout is pretty complicated, and it will surely take a lot of time if you manually try to get to the final positions here. If you haven't seen it, please watch our video about collision analysis in momentum forward method to see how this can be done manually. However, today we are talking about our automatic collision analysis tool, and that's how we try to solve it now. So it's pretty much straightforward. First thing you need to do is you need to specify the collision position. So placing cars in their assumed collision position. Please note again, like last time, that this is not the moment of a first touch, but rather the moment of the deepest impact, since we are making a momentum calculation and we need this idealized impact point. Second, we need to specify the final positions. And then we need to enter parameters. So what we can decide is, what do we know and what do we want to know? We have the position of the tangent and the impact point, which is like always very important, and we hardly can know that up front. With a K value, so the value that tells us or how elastic or plastic the collision is. So I'm giving it a range between 0.05 and 0.3. Coefficient of friction between the vehicles, since this is a 90-degree collision, standard value of 0.5 is okay, since this value doesn't have a large influence in these situations. Speed between 10 and 100 kilometers per hour. Brake pedal between 10 and 90% brake pedal position should be fine. Well, since this is a crash test, we don't need steering. And also we don't really need relative positions. So the cars, we could say, okay, car's a little bit further or backwards or left or right, or it comes in with a different angle. We could all set that up here. Once we have done that, we can click on calculate. And as you can see here, a counter is going up. Each number in this counter stands for one full simulation from start to end. And what Analyzer does is it will give you 10 completely independent sets of calculations. A reason for that is that there might be different sets of parameters that lead to the same final position. And this should give you greater certainty in that you kind of cover all possible combinations of values that lead to that final position. In most cases, it will circle around a certain set of parameters, but sometimes it actually can happen that with two completely different sets of parameters, you'll reach the final position. Imagine, for example, a situation of a car that's going very fast, but is braking strongly, compared to a car that's going very slowly, but also braking weakly. They both could end up in the same position. On the right, you can see a value called quality. Please don't mistake that for probability. The quality value is just a value for you as a user to tell if your results are good in the calculation process already, because if quality would always be 0, probably there are no combinations possible how this final position can be reached. 100 just means that there is an exact overlap between the wanted final position and the calculated final position. And you can see here in the second round there is already like almost perfect overlap. Please note that this tool is not designed to refine a certain calculation. It's not an optimization of a certain calculation. It's rather the first step how you can start into your report and get your first idea of what happened and why. So since the calculation is done now, we see the results, we see the ES values, and we can now select which values we like. Once we have found a version that we like, we can just click on transfer. What it will do is it will write the data into collision analysis, and it will write it into, as you know from our previous video, also kinematics. And as you can see here, 3 columns in our main data window are filled, and we can just press play and can do our pre-collision analysis with kinematics here, or we could go back to collision analysis and refine our results manually. As you can see, this is a very fast and easy way to deal with collision analysis. It has, of course, certain limitations, but we are striving to make them less and less, and that should speed up the process quite a bit. Hope you enjoyed the video, have a great day, and bye-bye.